I don't have it new. I don't know. Figure it out.
Oh yeah, I just had to refresh the folder. But yeah, now we're trying to figure out how long it takes to do. I mean, at least I can check with my dad.
Oh no, I got. It shouldn't take that long. I mean, because like my program was, you know, the one at the end was checking 8, 10, 12, 14, 16, and 18 on each one of these. So,
Okay,
and I
and
only
just,
took like 5 minutes.
just to make sure your program is working, should be 14
This is a 2214.
This can be
Here, and then it's going back up here. So I can tell you a lot of information instead of going here to almost 13,000. And that's whenever I stop taking time to refresh the document and reopen.
See, that's why I think the file is slowing it down because mine ran in 847.
Yeah, because it's constantly rewriting the file.
Yeah.
Some days. And this is already at 15,700. That's this one. I'm pretty sure.
I'll answer my phone and drop that one. Right off the top.
So it was a, like, did you do your scratch?
Yeah.
It was after.
I just,
Yeah, that's what I was trying to find out.
So you like you just did modules, like any modules for your last time.
yeah, the modules. Okay.
Okay.
How are you guys? Hope everybody had a good weekend. Good, good.
You're going off.
All right.
Your homework, let's talk about it before we go on. I know these ones use a lot of resources on your machine, so that's a fun part of it. So when you're doing 2214, if you have to knock these numbers down because of the performance of your machine or something like that, do so. One thing to be sure of though, make sure that the numbers that are coming out, your execution time, is looking accurate. Depending on which one of these algorithms the book says, you know, is the most efficient, we should be seeing it use less resources, right, than the others. Now, how's everybody doing on that one? We had all those listings already available. So we should just be able to set up a main method that runs each of them and grabs all that output. So let me know if you're having trouble with that, and I can sure help you with it, get it started, because that one shouldn't be super hard because you just want to use that code that they've already supplied. Now, the other one where you're doing the prime numbers yourself and trying to save that data file, that one is a super complicated one. The videos that are posted, there's a couple of them, and I kind of want you guys to use the videos because that way you can pause if you want to, or skip forward if you want to, or set it on double time. Yes, sir? Oh, that's too bad. You can download them. So remember, they're on YouTube. Download them beforehand and get yourself set up so that you've got them when you need them. So make sure you're doing that. I give you permission. So on YouTube, I think as long as the author gives you permission to download them, you're okay legally. But yeah, because if you don't have the internet, that'll suck. But you probably figured it out on your own.
Well,
Some. I'd like for you to watch the videos just to critique, and you can say, I didn't do it that way. Because there's definitely some flawed ways of doing things in this one. Yes, sir.
The way this prints out. I just
Uh-huh.
ran 2214. You can't tell where one number ends and the other begins.
So format your output when you're running things.
Yeah, the way they got it formatted.
Yeah, you'll probably have to do a little bit of work on that and see if you can get it all looking a little bit more readable. Definitely going to be challenging for you on this one. These two I know are that way, so get them turned in. If they're not working 100%, that's still something to grade, right? Because they're pretty interesting programs without a doubt. So between the videos and all of the other resources that you have available, I know that you can figure them out. It is a possibility. Before the videos, when people were just supposed to go do these on their own, I don't think that it was truly possible to figure them out because there wasn't really quite enough information. I tried to give you some extra. Yes, sir?
No, I was just
Thinking. Pinched nerve.
You're gonna hear that a few times.
Okay, we'll just ignore you then, as long as you're not yelling at us. Okay, so let's go on to our new stuff. I had it open. Let me close some of this junk. I've got too much junk open. I can't find what I was looking at. I think I closed it. I can get it open again real fast. Not that one. How about this one? Okay, so look at us move along. We're in week 11. Oh my goodness, it looks like week 10. You have a whole bunch of stuff. You do. You have a whole bunch of stuff again. A lot of them are videos, but we're looking at 2 chapters again this week. If you remember, last week we reviewed these chapters. Chapter 23 is about sorting, and chapter 24 is about implementing lists, stacks, and queues. So taking the stuff we talked about last week about lists, stacks, and queues, and just going a little bit further with it with a little bit more activities. So not too much additional information there. I'm going to be looking at this chapter 23 sorting PowerPoint. So if you want to download it, that's the one we'll be going through. Next time, we're going to do a sort walkthrough. So we're going to, by hand, go through some sorting and keep track of where our array positions are. There's sort of a video of that. It's much better if you can do it in person here, but if you can't, you can watch that video. Now, there is another extra PowerPoint here that we'll look at next time or next week. Again, 2 assignments. The first assignment is a radix sort, which will mean a lot more to you after we've talked about different sorting algorithms. And then the other assignment is an animation. Which exercises have the answers for you? The solutions. Is it the evens or the odds? Evens. So remember that as you're looking at stuff here that you have to do. So for this week, you may need to refer to the answers, but hopefully you don't need to. But if you're in an emergency, that's your option there. Okay, so I've got that PowerPoint open. I'm going to try to see if I can get it to work. It's just PowerPoint. I should be able to handle it. We'll see. Sorting. So we're talking again about data structures. We have that whole data structures class. So if you feel like we move kind of quickly to get through these concepts, that data structures class, we'll be able to focus a little bit more in depth on some of these ideas, give you some additional practice with things. But for today, we want to talk about sorting and sort structures. Whenever I started my job at Mutual of Omaha, the first assignment that they gave me was a program that had a problem. And they said, this program always prints out the wrong stuff. And every time someone new starts, we give it to them and ask them to fix it. And it still keeps not working right. So you can bet I was super excited because I was thinking, how am I going to fix this program that nobody else has been able to fix in all this time that they've given it to all these different people? And I looked at it, and it was this little teeny program. It had like 15 lines of code. And I mean, there just wasn't that much to it. It couldn't be doing anything wrong. So I looked at how things were set up they had what's called job control language that determined the order of things. And before this program ran, the data file was sorted. And then it was fed into this program to output this report. Well, it was sorted in the wrong order. And so when it came into this program, it made the program produce invalid results for years and years. I don't know why. Nobody had ever looked at the sort beforehand. I can't explain that. I can tell you it made me look really good starting off a brand new job that I was able to fix this problem that nobody's been able to fix for years and years, but it really had nothing to do with the program at all. Because I understand sorting, and I understand that data has to be in the right order if a program thinks it's going to be in a certain order. Now, for some reason at Mutual of Omaha, when you're processing people's insurance claims, for some reason there just tends to be a whole lot of sorting involved. And we can see that kind of in any sort of situation, any business application that we look at. There's going to be a lot of times we have to sort things differently. Because if I'm looking at a file that contains it, or a database table that contains information for every item that's been sold in the company, got the item number, who we sold it to, how many we sold, and those kinds of things. Well, if I want to create a report that tells our management how many we sell of each product, then I need to sort that data by product code, right? And then I can print out how many we sold of each product. If I want to be able to print out a report to tell our management how many of those products were bought by each customer, then I need to be able to sort it by customer and output it in that way. So if you've had the SQL class, you know that ordering your data, sorting your data is a really important part of SQL, of SQL, because that's a big feature of the database. It lets us do that so that we can make sure our data is in the right order. Well, sometimes we have to do it ourselves by hand in our program. And at Mutual of Omaha, one of the programs that we had to support had like internally within the program like 26 different sorts. So depending on what data was encountered, it would write all that data out to something, sort it, and output it some way. And then if it ran into something else, it would sort it in some other. So that program would run in about 18 hours, which is not good and not fun to fix. We want to keep those things separate. But again, sometimes we just have to sort the data. Sometimes our database sort is so inefficient that it's taking forever. And we can't just use that ordering because it's just costing too much time. Last week, if you remember, we looked at search algorithms, and we said a linear search started at the beginning of an array and looked at every entry in the array to see if it could find a match linearly across the thing. Then we said to really improve performance, we could change that search into a binary search. Remember, that's where we start in one half. Do I need to search the top half of this array or the bottom half? So I'm going to cut things in half literally by doing that. Same's true with sorting. Sometimes I might use one algorithm to sort something because I want to keep my code simple. But in another situation, I might need to use a really advanced, really complex sort to save as much resources, as much execution time as I possibly can. So it's going to depend on my situation. So let's look at a very basic sort called an insertion sort. What this does is kind of like, it's actually very similar to what's called a selection sort. So they're kind of like that selection searching that we saw. They just start at the beginning and they say, is this element greater than this one? If so, I'm going to swap them. Start at the beginning. Is this element greater than this one? If so, I'm going to swap them. So it's just going to very slowly work its way down the array to get things in the right order. So let's watch a insertion sort in action here. We have one guy who's seen these before. I apologize, sir. I think you're the only one. Let me stop it. So here's our array. Notice the index values across the top. The contents of our array are the labels on the people's outfits there. We want to get it in order. So those two needed to swap positions, but then there's a test. Do we need to swap anymore? Nah, so they clap. Now we do need to swap some more, right? He's still in the wrong spot. Finally in the right spot. Now somewhere in our logic, we're keeping track of where we left off, right? Because we didn't start over at the very beginning. We started over there kind of in the middle, which saved a lot of performance time, right? Because if we started over at the very beginning each time, that'd be a lot of resources. We'd never finish with this thing. We would be very sick of Romanian dancers. So notice our dancers' numbers match their index values once they get sorted. We couldn't take that for granted in just any set of data. That's just a coincidence with this one. Now they can dance because they've got their partners. They're all sorted up in the right order. And now we know that Romanian dancers do a lot of sorting. And look, their video is actually very long of them dancing, so we're going to stop. Unless you really want to watch them. Oh, look at them do that little kick thing. Isn't that cute? Okay. So there's actually all sorts of sort videos by the Romanian folk dancers. So if you're interested in more, you can watch them. But that's kind of an insertion sort. We're saying, does this item need to be inserted before this item? If so, I'll swap their positions. Now, what about a bubble sort? A bubble sort is a little bit different. In a bubble sort, I'm going to start out and try, as I traverse my array the very first time, I'm really going to be looking for the largest item in the array, and I want to move it all the way to the end. And then I'm going to search through my array and find the next largest thing and move it all the way to the end, so that I'm kind of pushing my entries to the top of the array. Now, the way they describe that, the larger entries are sinking to the bottom of the array. So let me reverse the way I'm describing it. Entry 0 is going to stay the low entries. Entry 47 and 48 are going to be our largest numbers. So let's look at a video of a bubble sort. Oh, look, it's wanting to stop. Stop it. I don't think this one has.
I like how they give the date in binary.
Yeah, it's very cute. There's not much sound on this one, or any, so you just have to watch. So we have our Lego stacks, and they're different sizes. And so with our bubble sort, we're wanting to find that biggest stack to move to the end. These guys had some camera issues too, but it's so cute. Our little guys are working. They're like, so far, we don't see a stack any bigger than this one, so let's keep moving it. Now, notice as we went through doing that, we didn't adjust anything else in the array as we went, right? We just every single time said, is this one bigger? If so, keep moving it forwards in the array, or towards the bottom, I should say. Now again, here our yellow stack is pretty tall. Is it going to be the next tallest? Nope, our white one is taller. So we're going to abandon that yellow stack there in that array somewhere, wherever we left off, and take that next larger one to the end. So it's bubbled, or sunk, I guess, sunk to the bottom. Now we want to, again, start at the beginning. We're going to look for the next tallest one. Should be our yellow one. That looks good. Now we can, he's double checking to make sure that they're at the end. And we really shouldn't need to double check that bubble sort, right? Because we know that first one was the biggest. So we don't need to retouch those entries. Remember from our big O thing, every time we compare something to something else, we're using resources. So if he jumps up there and touches those other ones again, he's wasting resources, right? We already know those have sunk to the bottom. They're our largest. Now, as you look at the ones that are remaining, even though we haven't been working at getting them in order, they are kind of naturally falling into being very close to being in order, right? Because as we're ending up leaving one when we find another bigger one, in effect, we're getting them pretty close. So pretty close helps in performance, right? Because that's going to take less resources than really, really far away to get back. Yeah, those workers, you know, they need that extra time. And that's all they've got to do now is flip those last couple, because as we were putting things in order, we really did get it really close. Shake hands, that's always good, be nice. This guy's going to do his one last waste of resources to check them all. He's got it, he's good. And then he's the lead guy, right? So he has to wait to get to. Everybody's happy. Now, I don't know if they're going to dance. We have a little bit more time left in this video. Oh, yeah, he's just going to do some kind of Lego dancing, I guess, there. Celebratory bubble sort dance. It's really an important thing if you didn't know. You'll feel it after you get your sort done. Okay, so that's a bubble sort. At the end of the first pass, if I was doing a bubble sort, I know that if I'm going to print out my array, at the end of the first pass, the largest number in the array should be at the highest number index of my array. So I can test my bubble sort pretty easily and make sure it's actually working as a bubble sort. Now, I could have students say, I turned in this assignment as a bubble sort, and it sorts the data, but it doesn't necessarily do it as a bubble sort if that highest number doesn't end up at the end. Okay, what's a merge sort? A merge sort is kind of like that binary search, where we're going to split things into pieces, into sections, sort up those sections, and then merge them back together. So now we'll be sorting some smaller pieces. This is my favorite 3D animation guy. He doesn't talk until he starts going in the room. So.
In this lesson, we are going to show how the sorting algorithm merge sort works. Its function is to divide the elements in the data structure into smaller partitions and sort them. Finally, must we merge the small partitions to make the original set with sorted elements. This strategy is called divide and conquer.
So he's dividing way out, right? Now his final merge, he's going to compare elements from each half to put them in the right order. So they're showing you that big O information on that one. As you can tell, the number of comparisons was substantially less than the number of comparisons our Hungarian dancers did, right? Because they were doing that inefficient type of sort, in which this merge sort, we didn't have to do near as much. But a lot more complicated of logic for us is coding it. Now, there's also a heap sort. I'm going to skip that video because it's just yucky. Doesn't really, it's not very helpful either. Okay, so a bucket sort. This is kind of like the one that you need to do in your sorting assignment. So let's take a look at it. What we're going to do is create some buckets or separate arrays to hold the data from our primary array. Then each of those buckets or separate arrays will be sorting their contents so that when we put all of our buckets back together in our final merge, we'll have everything in sorted order. So here's our numbers in an array. Now in this one, they made the buckets just be kind of ranges. For yours, you'll probably want to make the buckets be like, you know, 1, 2, 3, 4. You could do it that way. Lots of ways you could do it. Let me back up here because I took away from the magic by my talking. Scatter the elements into the buckets according to their ranges. So you can decide what the range is going to be because you are the one writing the program. Then gather all the elements from each bucket in order, and your end result will be sorted using the bucket sort. Super easy. The logic to do it is not quite as easy. Now I've got audio going.
But it's wordy and hard to read. It undermines the writer's message and the work.
Stop talking. Okay, so that's our bucket sort, which is very much like the one that you're going to do. So now let's look at some sorts here. So this is a selection sort. Insertion sort, which is very similar. Up at the top, they're showing you the big O information. This is a quick sort, which is, I want to say it's a Linux sort that would be available on some version of Linux. Notice how it's kind of a mixture between a bucket sort and a merge sort. So they're doing a small section and then merging it all together. Now here's an actual merge sort, a little different. And they're probably using, 5,000 entries or so, something like that, for their merge quantity. Whoop, and then it's all done pretty fast. Now this is the heap sort, the video that I didn't show you. You can look at that one. You can tell it's a lot like a bubble sort, where it's finding those large entries to put to the end of the array. But it's also doing some merging along with it. Now this radix sort is your actual assignment. So it's a form of a bucket sort. Faster, huh? Ooh, that's the one I want you to know how to do. Here's another radix. Just kind of hitting different sections of the array a little differently. This is a Linux sort, standard sort. You can tell it's kind of a merge. It's pretty efficient. It's a lot like Linux, where it gets things almost there and then finishes it up. Now here's another Linux sort, a stable sort. So depending on which version you were running, you would be able to find out which sort they used. This one is pretty much a merge sort. This is a shell sort, again, a Unix or a Linux shell. It's very quick. But again, you can tell how it's focusing on certain things and then coming back and focusing on more details. Just somebody had a brilliant idea of, I think I can make it more efficient. Here's our bubble sort. That's real common. This bubble sort is the kind of sort that the SQL server does by default. So that's why sometimes it's not as efficient as what we need. Here's the cocktail shaker sort. It's a lot like a bubble sort. It's finding the biggest and the smallest as it goes. Putting them all where they belong. Shaking it all down until it gets all done. That's a pretty efficient one. Linux, the GNOME release, this is the GNOME sort. And again, a real interesting one. This one is kind of, I don't know, it's its own, isn't it? Kind of its own algorithm. Bitonic. Bitonic is really interesting because it seems like they switch from a selection sort to a bubble sort and a radix sort, and they kind of do little pieces and then merge it all together. Here's the BOGO sort. We read up on it in C# last semester. It says it's not an actual sort. It will just keep moving data around and around forever and ever. So I don't know if that's why it's BOGO, like buy one, get one, or it just keeps moving things. I don't think so. It's great for the video. It would probably be good for randomizing or, yeah, something like that, like if you wanted to generate.
You want to do like a password generator?
Yeah, something weirdo like that. That would be a really good thing to use it for, something like that, because you'd have to be looking for some really, really random ideas there.
Did that one ever end?
No, the BOGO never ends. It just goes and on forever. So you just have to stop it at some point if you wanted to use it for something, if you wanted to generate some sort of number like he's talking about. Just pretty neat.
So it's a perpetual shuffle.
Yeah, a never-ending shuffle.
You get
Exactly.
information out of it while it's doing that? Or do you have
Or you in your code, you could make it stop, you know, if you decided, and do something, yeah, whatever you wanted to with it. So let's see what they have. Whenever we're working with all of these sorts, there's some things that can really help us. Let me get logged back in here, Pearson. You know, there's secret content. They have to log you off after 5 minutes. We wouldn't want an unauthorized student accessing your Pearson content. All right, so let's see where our sorting stuff is. 23. I'm going to go to the very beginning of the chapter. Now, as you can imagine, throughout this chapter, we have a bunch of different example sorts for us to code. But there's some really good things for us to think about in looking at these examples. Like they say, sorting algorithms, they really illustrate many creative approaches to problem solving. And these things will help you solve other problems. It's amazing. Secondly, the sorting algorithms are good for practical, fundamental programming techniques. We have to use a lot of loops and methods and arrays. And they're just really great for demonstrating algorithm performance. So we can do some things with them. Now, as we start out in our chapter, we're going to create some common methods that we can use then, no matter what kind of sort we're going to use. Whenever we're looking at our sorts for our assignments for our Java book, some things that we can assume. All of our data is going to be integers. Now, that's going to mean that you guys don't get an opportunity to do a lot of string sorting, but you've done that, right? And you've seen that with string sorting, you need to put in that compare to method and get all that stuff implemented so that you can do the string sorting. So we're going to focus with on arrays of integers with R's. Whenever we're sorting, we're going to be sorting in ascending order. So we won't be doing any sorts where we want our array to end up in descending sequence. In that way, we can just set up some programs where we can modify them really easily to work with other kinds of data so that we can have our sort algorithms be kind of perfect, as much as perfect can be. So let's start out with our insertion sort. But I think that before we do anything, we're going to create a method to build an array filled with random numbers. So let's do that first. I'm going to open NetBeans. Oh, look, I already have it open. Now, we've been doing really good with these different listing names. So let's start with this one. Sorry about that. I want to create a new project. Ooh, I need to close all these tabs. Let me get myself cleaned up here. I'm going to have a big mess and not be able to find anything as we get started. So I want to create a new project. And my new project is going to be listing 23_1. And if we can change that main class name to Insertion Sort. And I really want to have this Insertion Sort for us for next time. So I think we'll just go ahead and create it. I was thinking, oh, we'll create our load and array method first. But nah, we'll just create this Insertion Sort because we're going to use it next time. My NetBeans has slowed way down. I think they did some sort of update. I don't know, but the other day it took forever to create a new project. Seems like once it gets to going, it's okay, but there at first it's really, really bad. Is yours being slow or is it just mine? Huh? Is it? Okay. Just mine. Might have put, maybe I dumped some new GitHub repo in my H drive that's slowing things down. I should check. All right. So for our insertion sort, we're going to have our main method, and then we're going to have our insertion sort method. So not a lot of stuff in this one. Let's start out with some good comments. This is our insertion sort. Put you down as the developer. Insertion sort, listing 23_1. And we're just going to say our purpose is to sort integers using an insertion sort. Now these other Java generated comments are fine. Remember, sometimes when I look at your work, if it says that the author is, some name that is in no way related to you, sometimes I might ask you about it. And I'll get that email back. That's my girlfriend's computer. Okay. I just want to know. Okay, so let's create our first method here in this thing. It's going to be public, and we're going to call it from our main, so it has to be static. And one thing for us to think about while we're doing this is we're going to be working with arrays. So some of our methods may perform better if they're created static, so that we don't have multiple instances of them in memory. So this insertion sort is actually going to be the method for sorting our data. So this method will do the sort. Now it expects an array of integers as its parameter. And that's what it's going to sort. So our array is going to be called list in this method. That's what we put up there in our parameters. So we can use the length of that list array to control a for loop. So let's set it up. We want our for loop to be controlled by an integer named I, and we're going to start out at the first position of our insertion sort, or our array. And we're going to run this loop while I is less than the length of list, our array, and we want to add to I. Now, as we go into our for loop, we're going to create a variable called current element. and we're going to set it to whatever item our I variable is currently pointing at in our list. So it's kind of like a save item. We're going to save it. We're going to declare another integer named k, and then we're going to do a for loop using k. Now, we must need to access k outside of our for loop. Otherwise, we would just declare k within our for loop, right? But we're going to set our k equal to I minus 1 is its initial value. We're going to run this loop while k is greater than or equal to 0. Find my 0. And we actually have another criteria for testing for our loop. We want k to be greater than or equal to 0, and we want the item that's pointed to by k in our list to be greater than our current element. And we're going to subtract from k as we execute our loop. Now, if our condition is true and we execute this inner for loop, we're going to update our list. We're going to say, hey, take that element at position k plus 1 and set it equal to the element at position k. That ends our k for loop and ends our I for loop. And in between the two, we want to add a line of code. So when our inner loop is done, we're going to update our list at position k plus 1. And we're going to set it equal to that element we saved, our current element. That for loop there is our total sort. That's the whole thing. Now, we need to create an array to be sorted, and we'll run the sort. So let's create that array in our main. So our main is going to be our tester. So let's start out just declaring an array of integers. We call it list, whoops, and we'll set it equal to some initial values. Now, when we start here looking at this section, when we're talking about sorting, and all of these data structure sections, I'm acting like you guys are old pros working with arrays. And you might feel like you're an old pro working with an array. That's great. You might not feel like an old pro working with an array, and that's okay too. So any questions like that, remember, you're probably not the only one. So just ask, because I kind of believe in programming by immersion. That's like if you go to a foreign country and you only you only speak that language, they say, you learn that language, and it's kind of painful for you, but you learn that language very quickly and very well. And that's kind of how we program, right? Because we're going to be in this room, I just talk like you know all these things I'm saying. So let me know if you don't. Okay, so we created an array of integers. It had its initial values, so it got declared and instantiated. And now we're going to call our sort, insertion sort. And we want to pass it this list array that we just created. And then let's print it out. For int I equals 0, I less than list dot length. I want to add to I. And for each of those, I want to output my list item at position I plus a space. Now let's run that. And we should see our data come out in a sorted order from our print. Haha, it worked. How about yours? Did it work? Yay, yay, yay.
So I have a question.
Okay.
So on line 25,
Mm-hmm.
what does that do? This K plus 1 equals current element? Because then you just restarted the for loop.
Yeah, we need to do the sort thing. Let me find it because I thought we would want to do that tomorrow. Let's see. Where are you guys on your assignments for tonight? I don't want to use up your lab time.
I'm done.
You're done?
So was that,
You're not, you're not, you're not, you're not. Okay, let's save that question because that is a very good question. Let's save that for next time and we'll step through this sort together and we'll look at every statement because it's really going to help to do that. But I want to stop now for lab time for today since you guys have those big assignments due tonight, and then we'll step through it next time. Sure. Any place else that anybody needs to see, let me know. But really, I want you guys to have lab time. So if you need help, hang around. If you are wanting to help, hang around. Otherwise, have a great day.
What did you say the solutions were stored in? There was a file she used.
Hmm?
What did you say the solutions were stored in?
Down at the very bottom in that supplemental information.
Your videos go through them all the way.
Mhm. But I don't have, I'm sorry, Chris, you'll have to download them from YouTube because I don't have them saved or anything. Do what?
We should write.
Find a special website.
We should write just faster down. Premium channel,
Yeah, I tried to save them for a while and
or at least
stopped.
last time I checked.
So I just always use those other sites.
For this one, I'll just do it. We're wanting to see, measure how long it takes to find all the prime numbers, naturally run and take release. Or like one.
They want you to try running all three of these with this number. Then try running all three of them with this number.
Okay.
So they kind of want to tell you how long it took. So you might have to take a couple zeros off those. Depending on your system,
Okay.
run a comparison.
Gotcha. So basically you just like do the start time at the beginning and then start time minus end time.
Yes, perfect.
Sweet.
I'm catching it. How are you? Did you make it on your trip?
Okay.
Yeah, I was really happy I don't have to
Of course.
Just one of those days, weeks.
What was that,
2220. Six or whatever, is that one? 2220. Because that one you're copying through all the way that's already out there, and you, so you're gonna set up your own page to figure out how long until there's no.
Oh, so you can have it all in the same package.
Right. But other than that, you don't have to spend a whole lot of dollars on that one. That other one is pretty tough. Yes, yes, and that one, you know, I'll. Why you just talking about this? That's grabbing the last two things. And when that lets you not order this, say number right. And then
We're doing that.
A little bit, but I have a trouble with it. Yeah, yes.
Are you still writing down? Are you doing the
I
sort?
complicated. I thought she had some good videos for it.
Someone. Sorry, no.
Yeah. Someone else's cozy. This way. Like frogs. See, that was so bad. The chalk is pretty cool. Yeah. The nicest alternative. Yeah. I guess you can, like, I really wanted to use I put it on, but there's so much stuff. It's crazy. It's hard. No, yeah.
No, I had to close it. Oh, I'm a child. Will be 0, so it's sort of the first one. And since the first one, I create 12, 3 divided by 2 is not equal to 0. So there is an actual closing of this.
Oh.
And needs to be a closing of primaries instead of dot reparation. Well, it does not contain a tree, so it triggers the tripwire. Now you need a semi-out on the end of it. It's perfect. It will go through. And it is not true. It is not true. It does not contain. It does not exist. Therefore, tripwire. So it is not true. Oh, we're missing one line because of it. Yeah, this line right here. In between your loops. After the K loop, but before the end of the I loop. Now, why is not initial? Why is the last index of prompt? And each time it goes to clear. So I have to look at originally is 2. So 2 plus 1 is 3. So 3 does not trigger.
Oh, okay. This is the same way.
Does not.
Oh, that's C#.
Sure.
What?
So these are the questions. I just put them in saying that it is the classes.
That's what I have. You don't change anything. That's right.
No,
I'll write
I just leave them there. And then you have the begin time.
And that's for each.
That's for each one. Actually, these are for each one.
So I think I was just trying to do one for all 3. Which really confused me because that wasn't true.
Yeah. Well, mine's in my name.
It's still right.
What's the matter?
But these are all the same.
Because I have it's because I have a method for this, like what she talked about in the video, because was that. So you just created different variables that keep track of your time with those sort. I know that.
Oh, it's just putting them out again. Begin time, end time, and then advance it. And then the prime time. And then this, I don't know what that is.
The beginning time stuff.
Do you call your sort?
No.
So you're just flipping through the beginning. So
It is the same. You figured it out.
Each value.
yes.
Well, you're not Because you're implementing the.
That's a little better.
Or, you know, each time you step, right?
Yeah.
You're beginning to don't have to apply that much.
Right. Why won't this one? I already submitted it. So it's paid.
Pretty sure.
Yeah, I did.
Well, if it's not there.
Sometimes in that means I think it's conclusive.
Yeah, it's nuts.
That's right.